Hey everyone, Wilfred here, and welcome back to Wilfred The Analyst. If you are new here, don't forget to hit that subscribe button and ring the bell for all the latest updates. Today, we are diving into the world of time series analysis. Specifically, we'll be exploring how to test for a unit root using the Augmented Dickey-Fuller test in Stata. This is a crucial step in understanding the stationarity of your time series data. But before we jump into it, a big shout out to all our subscribers. We are on a road to 500 and I can't thank you enough for your support. If you haven't subscribed yet, now is the perfect time to join our growing community. Hit that subscribe button and let us hit our goal together. Thank you. Alright, let us get down to the business. The Augmented Dickey-Fuller test, or what we call the ADF test, actually is a powerful tool for checking whether a time series has a unit root or not. A unit root suggests that time series is not or is non-stationary. Now, in Stata, performing the ADF test or Augmented Dickey-Fuller test is a straightforward thing, and there is the step which I'm going to demonstrate now in my screen. As you can see, my last video or the previous video, we did the banner unit root test in Stata, and actually this is the same data that I used. If you watch my previous video, you'll be able to see even this kind of the codes. Now I'm going to use the same data, but now there's one trick that I'm going to show you. Because if you look at this data, if I execute all this up to this stage, now you'll be able to see first I've cleaned my data. The data now has no missing data. You can be able to see the newly generated variables, which you can also watch on my previous video on how I did it. And now these variables are into 2 decimal places. You can see the original one here, GDP was to almost 6, but now you can see it is 2 into 2 decimal places. However, you can realize that this data is not the cross-sectional. Actually, it's longitudinal. It's not a time series data, because you can see we have more than 14 countries in this case. Sorry. Now, one trick is that I'm going to show you on how to from this banner data, how can you extract just a time series data and continue with your time series analysis. Basically, you can just do this like this. Let me start from here. I can say this is time series analysis, so it's just a continuation. So what I'll do, I filter the data. I filter the data, and if I come back to my data, so I want to select, let us say we want to work on Algeria. Let us just call the first country, which is Algeria in this case. So we're going to work on the data from 1973 all the way to 2022 for one country instead of 14 countries. So by doing that, it means that now we'll be working on a time series data and not banner data. So what I'll do, I'll just go to my code here and I'll just say keep. So I'm now filtering the data. Keep if ID. So we already have ID in our data. Is equal. We call this equal to 1. So like I'm commanding Stata like to keep only the data that belongs to ID number 1. Then all the other from 2 all the way to 14 now will be excluded from the data. So if I do that like that, then I execute. Perfect. Now you'll be able to see we have remained with time series data for only Algeria for ID number 1. You can see ID number 1, and now this data runs all the way from 1973 all the way to 2022. So we have excluded the other information. Now it seems at this stage now we have a time series data. So, and this is the data that we are going to use to demonstrate that time series thing. So you can start, you can just at this stage you can do even a symbol descriptive statistics. You can use sum. Let's use sum. Yeah, sum, then GDP, DI, and inflation, and I'll be able to see, like, on average the GDP growth for Algeria is actually 3.15%, with a minimum of negative 1.51 and 9.2 and so on. FDI, you can be able to see, is around 0.67, and the other inflation rate is around 8.9 on average. Now, so let us go direct to unitary test, actually, which is so it's an important thing, because when we have a data like this, we need to see the trend, So for us, maybe if we're going to do like advanced model, like maybe our regression models, maybe VAR and so on, so your data has to be stationary. So what we are trying to do right now is we are just checking out, is this data stationary or not? And if it's non-stationary, then how can we convert it to stationary? And after we now acquire the stationary data, then now we'll be saying now that data is just ready for data analysis or for subsequent analysis. So what you do, the first step is just to declare your data as time series, because right now I can decide to use a time DS line. DS line just mean time series line. So like I'm trying to plot a graph for GDP, for instance. So it will give me an error. Yeah, you can be able to see it give me an error. It tells me that time variable not set, use TSST variable name, and this is an error. So first you need to declare your data as a time series. So you just go to statistics, go to time series, declare data set to be time series data, just like that. Then you select time variable, which is in this case, which is year, and the data is in yearly. So if your data is in quarterly, daily, weekly, so you just because right down here there's something you can be able to see TY, and if I just say monthly, so time TM, time monthly, you can be able to see weekly, you can be able to see daily, how this changes here, you can be able to see clockwise, you can be able to see quarterly, how it looks like, TQ, and so on. But this data is specifically for yearly, just like that, and you press OK. Then it means once we get this message, then we are ready to do n time series test or analysis, since we have already declared this data to state that this data set is what is time series data. And you can be able to see it runs from 1973 to 2022 with a difference of 1 year in between. So like there's no that gap, so it's just 1 year difference. Then now if I just swore, and if I repeat this times line approach, DS line for GDP, for instance, GDP growth, just like that, and I press enter, perfect. So I'll be able to get a nice graph here. If you look at it, let me do like that. Good. Now you can be able to see a time series plot for GDP growth, which is annual percentage, and you can be able to see the trend, how it's moving. You can be able to see how it's moving. You see how it's moving, and actually, if you are a keen around here 208, remember we had something on financial recession, like it's down here. So it's, if you look at around the 2019 to 2020, around there, it's worse. The GDP growth is worse. Actually, this is due to COVID-19, the pandemic. Remember, it was tough. It was because this is a novel that hit almost each and every country in the world. So you can be able to see how it's moving. But looking at this data is actually not stationary. Now I'm going to show you one trick for you to ensure that the data is stationary. Now you can use two methods actually. What we are going to do is to use the augmented Dickey-Fuller test, or you can use a graphical method. Graphical method now is where you use this time series TS line plot to ensure. Sometimes it's tricky. I mean, sometimes it's confusing because you might run a test, let us say augmented Dickey-Fuller test, and they give you a significant maybe output, but when you try to use a graph, you find out that this data is not stationary. So you need to be careful. Like, you need to be in that position whereby if you opt to use any of the method, either graphical method or the test, then it just gives you the same output. So that's the main goal, and now that's what we're going to do in this case. And how do you see, how do you know from the graph that the time series, this time series data is stationary? It's just simple. We have zero at this point. So if you see all these trends in just Raymond's language, actually all these trends will be passing around the value 0. Okay, let me just put it like that. If you see all these trends within the value 0, like everything moves around this value 0, then now you can say at that point that your data is stationary. So that's a trick or something that you need to embrace here. Now let us start with the GDP growth. Now I can go to statistics, go to time series test and augmented Dickey-Fuller test, unit root test, just like that. Then select the variable, now GDP. Now you can include the trend time regression, and you press OK. Let's assume the rags, we just leave it at 0, press OK. Now if you look at this, actually from this output, I can just say that the data is stationary. Now there are two things that I look at. One, I reuse the test statistic against the critical value. Normally by default we use 5% critical value. Number two, I look at the p-value. So those are the two things you can use. So you can either use the p-value, or you can either use the test statistic against the critical value. Now if I'm using the p-value, you can see at 5%, this p-value is statistically significant, and if it is statistically significant, then we reject the null hypothesis. And if we reject the null hypothesis, then we accept the alternative that says the data is stationary. Another method to use in this case is now test statistic against critical value. We use absolute value. Like if the test statistics is greater than critical value, then we conclude that the data is stationary. But like for instance, negative 4.598 is it greater than or less than negative 3.504? Okay, most people they will say now this negative 4.598 actually is less than negative 3.504, which is true. But in this stationarity test, we use absolute values. So absolute values, we mean that now we assume the negatives. Then we say now absolute value for this negative 4.598 is actually 4.598. And the absolute value for 5% critical value of negative 3.504 actually is 3.504. Then we say that since 4.598 is greater than 3.504 at 5% critical value, then this data or this series is stationary. But looking at our graphical method, actually it's not stationary. So you see there are some confusion there. So what to do? I think now to be for it to be perfectly stationary, I think we can move to fast differencing. So how can we achieve this fast differencing? It's just simple. Just say generate. We are generating a new variable. Either gdb. Let us call it just gdb underscore diff. Just differencing. I normally use in my analysis. I normally like using this. Is equals to d, just to show the differencing thing. Then the original variable, which is that. Then I just press OK. Then you'll be able to see the missing value generated, and now that the new variable gdb underscore df has been generated, and you're going to be able to see it here. And if I go back to my data, now I'll be able to see that variable at this point. Good. Now what I'll do now, the next thing is that I'll move to, okay, let us start with the graphical method, not assume. tsRine gdb underscore diff. Perfect. I want, because you already show the first graph, maybe you can rewind the video back and you see the time series graph for the GDP growth. Initially, actually it was above this zero value, and I told you earlier, for you to be sure that the data is perfectly stationary, even if from the test itself you get that it is significant, just rely on this graph if you have a time series data, because you'll be on a safer side. Now look at this, like everything is buzzing along the value 0, up down, like everything, like this trend actually is touching this value 0. So you can see like almost everything now is aligned around the value 0. So now from this graph, a first differencing graph, now I can confidently say that now this data is stationary. So if I go back again and do the using the ADF, I can just go there, test, augmented Dickey-Fuller test, and like this time I use gdb diff. Perfect. You'll be able to see now actually it is perfectly stationary. So you can see significant 0.00, and you can see the test that's in this point actually is 10.362. Previous one was 4.598. So at this stage now we can conclude that the GDP growth actually is stationary at fast differencing. So it means now at that point we have converted that variable to stationary. So let us see the next variable actually, which is INF tsRine. Let us with the foreign direct investment and see what it gives us. Look at this. Actually 0 is at this point, and everything actually is not stationary. It's not stationary at all. It's non-stationary. Okay, let us see through. What if we use a test? Come back here, time series test here, augmented Dickey-Fuller test. We select the FDI, press OK. Oh no. Okay, look at this again. Absolute value 3.587 actually is greater than 3.504, and you can see the p value is a statistical significance of 5% because it's less than 0.05. Then if you use this test, then you can just say, oh, the data is just stationary. But no, just look at that graph, it's not stationary at all. So it seems now this data actually, this is now the situation where you need actually an expert, especially when you are handling this data, because if you are just doing this in a rush and you don't know, because there are so many techniques that you can use to ensure that your data is stationary. It's not just maybe augmented Dickey-Fuller test, different tests, you have different maybe approaches, but that's just a hint or a breakthrough that I'm just giving you. Now let us do the same thing. We generate generate the inf underscore no, it was f called diff is equals to difference, and then we have return and we press OK. So the same thing happened. So right now, if I plot a graph DS line foreign direct investment, I press OK. Perfect. Look at this. Now you can see this is now stretching down all the way from 2 to -2. Now, like at some point, it's cutting at the value 0. Like now you can see everything is aligned along like this trend. At some point they are cutting along the value 0. So that's a unique thing that you need to use as a breakthrough if you are having this kind of analysis. So if right now I'll go back again, do time series, I go to unit root test, and then the Dickey-Fuller test. Then I use FDI first differencing. You can see it is perfectly it is perfectly stationary, because you can see the absolute value of test statistic actually is 12.51, which is greater than the absolute value of 5% critical value, which is 3.51, and you can see the p-value is statistically significant at that point. Which now tells us that our conclusion in this case will be the foreign direct investment series actually is stationary at fast differencing. So I think you can be able to concur with me with that. You have seen that. Now let us move to the last series, TS line, INF, inflation consumer prices for Algeria. Look at that. Oh, look at this. Look at this. The 0 is down here. You can see everything is above 0. Majority is above what? Above 0. So this is not actually perfectly stationary. So if I'll go to statistics, let me go to time series. I go to test statistic, or the Dickey-Fuller test, and I select INF and then press OK. You'll be able to see. Now this one is worse. Actually, the absolute value in this case is 2.437, is less than 3.504, and you can see the p value is not statistically significant. Then we can just say this inflation or consumer is not stationary at its level form. So if it's not stationary, we have to make it stationary maybe at fast differencing. So we generate INF underscore diff is equals to differencing INF, like that, and we just enter. Perfect. So if right now I have the same graph for this newly generated variable and press enter, I'll have a nice graph here, time series plot. So let me maximize this, be able to see. So look at this, look at this, 0, like everything now, the trend actually at some point they are cutting along this value 0. Look at this, along this value 0. Look at this, it is arranged along the value 0. Now this tells you that now at this point the data is stationary. So if I go back and repeat the result again, the test, go to Augmented Dickey-Fuller test, then this time I'll use the first differencing and I just press OK. Wow, look at this. Now this p-value is statistically significant. The test statistic, which is the absolute of this, is actually greater than 5% critical value, which tells us now the inflation or the consumer price, actually series is stationary at fast differencing. So up to this point, now what we have done is that we have prepared our data like to be fast, like stationary. Then it means if in our subsequent analysis, so if we want to do maybe Fieri model, lag selection. So there are so many things. For instance, lag selection, you want to do the lag selection, blah blah, and so on. So this is now the data that you are using. For instance, if by the way, if I want to do the what? If I go to time series and now time series, then just go to what? Sorry. Okay. Yeah. So if you go to time series and go to multivariate time series, now go to vector auto regression. Okay, just like that. Then it means like in this case we are going to use the stationary variables, not the non-stationary. Just like this. We'll select the FDI, then select the stationary one. Okay, we have not done a lot here because there are some things that we need to consider. For instance, the lag selection. How many lags does this model supposed to consist? I've not done. So our next video actually it will be all about that. How to do lag selection, how to do the Johnson co-integration tests, all those bread tests that we are supposed to do. Maybe for co-integration now we'll be using it to maybe to tell if there exists a long-term relationship between the variables or not. If there exists that kind of, if the variables actually, if the series are co-integrated, then at that point we are not able to do we are not supposed to carry out the vector autographs model. Then at that point we'll be able to carry out the FEM model, the V is M model. But just this was just by the way, to just press OK. Then now you'll be able to have a VR model. But please, I'll scream also at this point, don't use this in your maybe in your study and or your project, because this I've not confirmed whether VAR model is appropriate for this data, because I've not done that selection. I've not done the co-integration, which are crucial, which will let me know which is the model maybe to use with how many lags or not. So this was just a by the way. But you can see what I was trying to now demonstrate is that now for your subsequent analysis after stationarity test, now you only use those variables that are stationary. And that's what we have just done right now. And if you go to our data, you'll be able to see the three stationary data variables. They are being represented at that stage, and now you can now use them in your subsequent analysis. I hope up to this point you have enjoyed this video and you have learned something. And the one request, please help me to reach 500. Please subscribe to this channel if you are new. Hit that notification bell again so that you can get updates. So because there will be a lot of videos from now henceforth. There will be Q&A session. If you have any question, live streams, we'll be able to have them so that you can have one-on-one discussion. So don't be left out. And also, if you have and difficulties, let us say you have your project, maybe you're working on a certain personal project, maybe you need help in reporting, data analysis, then I got your back. Actually, just an introduction about me. Actually, I'm a data analyst and a statistician by profession, and I have several services including markets and sales analysis. We have data modernization, data visualization and representations, data correction and surveys, dashboard reports, data analysis, also consulting and trainings, data management, and so on. So if you have any problem, I can call it a problem, I cannot call it a problem. If you have a challenge, maybe you want to do something, you are not sure about it, then just reach me out. If you just explore my channel, you'll be able to see my email there. Just send me an email and I reply immediately, and we'll get in touch and solve that problem. I hope you enjoyed. Thank you. See you next time. Bye.